Started since it is 11. This section, and we won't even get through all of it today, 8.4. This is the one that we were going to do Friday before spring break, but it was just too much to cover in one day, and I didn't want to split it to before spring break and after spring break. So now we're going to start it now, and we'll finish it on Wednesday. Now, what this section is going over is, remember, it's kind of going backwards from what we've done before. Before I get to some problems, let's just remind ourselves if we had a polynomial function like this, and it was asking us to find the zeros, right? We did a lot of finding zeros and talking about zeros. Well, what zeros are the x-intercepts of a function. This one, since it's quad, I can put that in my quad program to find the two zeros or to find the x-intercept, or I could factor this. It's not too hard of a factoring problem, right? I would do x and x for x squared. Factors of 15 that add to 8 would be a positive 5 and a positive 3. Then what would I do with these two factors? Once I factored it, I set each of the factors equal to 0 and solved them for x. So here I would have had to subtract 5s from both places to get x equals negative 5, and here I would have subtracted 3 from both places to get x equals negative 3. Those, if I put this in my y equals and graphed it, it would cross the x-axis at negative 3 and negative 5. That was finding the zeros, or the x-intercepts. What this section is going to do is give us the zeros and ask us to work backwards and come up with the polynomial function that those zeros came from. So this is what I mean by working backwards. So if you think about this, where did this 0 come from? It came from that factor, right? This factor gave me that 0. This factor gave me that 0. If I wanted to go from here to here, what's the opposite of doing the factoring? Foiling. So that's what we're going to do. They're going to give us the zeros. We're going to turn those zeros into factors. And then we're going to FOIL those factors to come up with the polynomial function. So we're just going backwards here. Let's look at number 1. Says find the polynomial function of degree 3. The degree is going to be what the highest exponent is of the polynomial function. So degree 3 means once I do all this work, I'm going to end up with an x cubed to the 3rd power as my highest exponent. So degree 3 with real coefficients that has the given zeros. The zeros that it gives me are negative 1, 2, and negative 3. So, like I said, remember where we had the zeros at the bottom of that last problem that I just put up here? What I wanted to say is, what factors did those zeros come from? And wasn't it always just kind of the opposite sign, x, then the opposite sign with that number? So if this is 0 is negative 1, that means it must have come from the factor x plus 1. If this 0 is positive 2, that means it must have come from the factor x minus 2. If this 0 is negative 3, it must have come from the factor x plus 3. So there's my factors. To come up with the polynomial function, I need to multiply all that together. That is where this section gets very tedious. Okay, it's not hard. We can all do the multiplication. It's just that if you make one little tiny mistake anywhere, it throws the whole problem off. Okay, so, and it doesn't matter what order you multiply these together in. So the first thing I'm going to do is just multiply these two parentheses together. So x times x gives me x squared. My outer, x times negative 2 gives me negative 2x. My inner, positive 1 times x gives me positive 1x. And my last, positive 1 times negative 2 gives me negative 2. And then a lot of times after you do that distributing or that FOIL, there's going to be some cleanup work to do, right? Look at these two terms in the middle. They're both x's, which means I can just put them in the same basket. So let's see, I've got an x squared. I'll put those x's together. I've got negative 2x here and positive 1x here. So that'll give me negative 1x. Bring down that minus 2. So that's what I get when I multiply these two factors together. So now I have to multiply this x plus 3 is just going to come down, right? I haven't done it yet. And then I'm going to multiply those together, okay? Now, a lot of times we just use the word FOIL when we're talking about doing all this distributing. So I'm going to multiply, let's see, the x squared will go to both of those. So x squared times x, there's where your x to the third comes from, right? They told us it was going to be degree 3 when we were done. So x squared times x gives me x to the third. X squared times positive 3 gives me positive 3x squared. So I'm done with the x squared. Now I'll move to the negative 1x and multiply it times both of these. So let's see, negative 1x times positive x, or in other words, negative x times positive x gives me negative x squared. Negative x times positive 3. So that's going to give me negative 3x. So I'm done with the negative x. I've distributed it to both of those. And now I'll just do the negative 2 to both of those. So negative 2 times x gives me negative 2x. Negative 2 times positive 3 is negative 6. And again, a lot of times after you do all that distributing, there's going to be some cleanup work involved. Putting your like terms together. This is my only x to the third term. I've got multiple x squared terms, which means I just need to put those together. Here I've got a positive 3, and here's a negative 1. So 3 minus 1, that gives me 2x squareds. And then put my x's together. So here I've got negative 3 and negative 2, so that gives me negative 5x's. And bring down the minus 6. So, polynomial function of degree 3, so its highest degree is the 3, with those zeros. Now, just on this one, just for funsies, I'm going to put this in my y equal. This is your answer. You're done with the problem. Put that in your y equals and graph it, and what should occur? If you graph this polynomial function, it should cross the x-axis in those 3 spots. So I'm just going to put it in my y equals. Again, I'm not going to do this on all of them, just this one, to just kind of tie it all together, to show you that this all does tie together. So let's see, x to the third, plus 2x squared, minus 5x, minus 6. So just in my y equals, I just put what I came up with. Now let's graph it. Look at where it crosses the x-axis. There's your negative 3, -1, and +2. Right? Do you see that that's where it crosses when you put that in? It crosses. Did yours do it, Abby? No. Let me see what you put in. But yeah, so it's going to cross at those 3 spots. Okay, let's look at number 2. All right, another polynomial function. This time my zeros are 4, 3i, and -3i. So remember, we're going to go from the zeros to the factors, and then multiply the factors together to get the polynomial function. So remember, going from zeros to factors, it's really just going to, this is going to be from what? X minus 4. This will be x minus 3i. Since that one is negative, it came from x plus 3i. Now, when you are multiplying, remember multiplying is commutative, which means I can multiply in any order that I want, right? Doesn't matter what order you multiply 2 numbers in, you're going to get the same thing, right? 2 times 3 is the same thing as 3 times 2. If you have 2 of your factors and they have i's in them, you want to multiply those together first. You wouldn't want to multiply these 2 together. That's going to give you a nightmarish mess, right? If you try to multiply these. Multiplying these together, though, actually kind of cleans itself up. So again, if you have i's in your factors, multiply those 2 together first. So let's do this first. So I have x times x. Give me x squared. My outer x times positive 3i gives me positive 3xi. I'm just going to write the I in the back. If you write ix, it's really not that big of a deal because you'll see why in just a second. But the I is different. It's not like an X, right? Your I is just the imaginary part of this problem. The I stands for something different than all the other letters. Okay? So then here, my inner, -3 xi, and then my last -3i times positive 3i is -9. I squared. Now, here's why you multiply those together first. What happens to these middle 2 terms? They're just going to cancel each other out, right? They're positive and negative of the exact same thing. Now, I can't remember if we've talked about it before, but remember, anytime you have an I, but it's squared, I squared is always equal to plain old -1. So this really says what? -9 times -1, which actually turns this into +9. So what I'm left with after I multiply all this together, I'm left with x squared plus 9. So that's why you want to multiply the I factors together first, because it cleans itself up. I still haven't done the x minus 4, so I just bring that down. And now I multiply those 2 together. So let's see, x times x squared gives me x to the 3rd. X times 9 is 9x. My inner, -4 times x squared gives me -4x squared. And my last, -4 times +9 is -36. Now, there's not a lot left to do, there's no like terms like the last one, but I do need to flip-flop these two terms, right? Because you want your highest exponent first and then go down from there, which means if I start from x cubed, I need my x squared term next. So I have x to the third minus 4x squared plus 9x minus 36. Now, just another something wonky, when you're putting in this answer, it's got a lot of this here for you. It's got x cubed minus blank x squared plus blank x minus blank. So this kind of threw me off when I was typing in my answer because I was like, and it probably wouldn't do you. But when I did the x squared, I put the -4 then, but it's already got the minus, right? So you're actually just plugging in a 4 there because it's already got the minus. Plus 9, again, here, it's already got the minus for you, so you're just putting in the 36. So it's just kind of weird how you type in that answer. All right, number 3. All right, same thing. It's giving us 3 zeros and asking us to find the polynomial function. So first of all, turn the zeros into their factors. So this one will be x minus the square root of 5, x plus the square root of 5, and x minus 4 will be its 3 factors. Again, I'm going to do these two first because just like the last one, when you see i's, you want to take care of those first. When you see square roots, you also want to take care of those first. And here's the reason why. You'll notice these two things are called what's called conjugates of each other, which means everything's the same about them except their signs in the middle. If you multiply two conjugates together, the outer and inner terms, when you combine them, are going to cancel. So that's why it cleans itself up when you multiply two conjugates. Like, watch this. X times x gives me x squared. Essentially, I don't even need to do my outers and my inners because I know they're going to cancel anyway. Because what's the outer? Positive x square root of 5. The inner is negative square root of 5. And then my last positive times negative gives me negative. Since both of those 5s are under the square root, I do multiply those 5s together. So it's going to give me negative square root of 25. What happens to the middle two terms? They cancel. Again, that's going to happen every single time when you are foiling. And what you're foiling together is conjugates of each other. The middle two terms will cancel out. So now I'm just left with the x squared minus, what can I write instead of the square root of 25? What is the square root of 25? That's just the same thing as saying plain old 5, right? So I can just write that as minus 5. So that took care of multiplying those together. Now I need to multiply that times x minus 4. And just FOIL that. My first x squared times x is x to the third. My outer x squared times negative 4. So negative 4x squared. My inner, negative 5 times x is negative 5x. And my last, negative times a negative, turns that into positive 20. So when I look at these four terms, everybody's in the right order, and nobody even combines, right? So that's as far as that one can go, because you can't, none of those terms have the same exponents. So none of them are like terms. All right, number 4. Same thing. My zeros are -1/5, 0, and 3. So if my 0 is -1/5, that means it came from x plus 1/5. When your 0 is 0, that means it just came from x. You could think of it as coming from, don't write this all the way out, x minus 0, but x minus 0 is just the same thing as coming from x, right? X minus 0 is x. So when your 0 is 0, its factor is just an x. And then the last one's factor, since its 0 is 3, that means it came from x minus 3. Now, remember, when you're multiplying, the first thing you're looking for is if any of them are conjugates, right? Because those clean each other up. None of these are conjugates, which means I can multiply this in any order that I want. It doesn't matter. So I'm going to multiply that one first. And the only reason I'm doing that is because I'm just avoiding that fraction as long as I can. So if I multiply the x times this, I just distribute the x through there. So x times x gives me x squared. Minus x times 3 is 3x. So that took care of multiplying those together. Now I will just bring down the x plus 1/5. And I can no longer avoid the fraction. So let's see, my first x times x squared gives me x to the 3rd. My outer x times -3x gives me -3x squared. ⅓ times x squared just gives me positive 1/5 x squared. And my last 1/5 times -3x. So if you wanted to, if you didn't want to multiply that out, multiplying fractions is not hard though. It's the adding and subtraction with different denominators that makes it get more difficult. But this, if you're multiplying fractions, you just go straight across on top and bottom. So that's just going to give me -3/5x. If you didn't want to think about that and you just wanted to type it in, what do you need to know? I need to know what 1/5 minus 3, or excuse me, 1/5 times -3 is, right? We'll just tell your calculator that. 1/5 would be 1 divided by 5. Now I need to multiply that. So times, I'm doing positive 1/5 times -3. So times -3, get your weird decimal. But what do you do with decimals when you need them to be fractions? You just hit the math button and then hit enter twice. So that's going to give you, there's your -3/5. And what do you have -3/5 of? -3/5 x. After you FOIL, look at your middle terms. They're both x squareds, which means I do need to put them together. So I have x to the 3rd. Let's see, what do I need to do? I need to know what -3 plus 1/5 is. So I'm just going to tell my calculator again. -3 plus 1/5, which will be 1 divided by 5. Hit enter, get your decimal. Math, enter that. So there is what -3 + 1/5 is. It's -14/5. And those are putting the x squareds together, right? So this is just going to give me -14/5 x squareds and bring down the -3/5 x. All right, so far, everything that we have been working with has come from 3 zeros and ended up degree 3, or x cubed. And those even take a lot of work. But look at number 5. Find a polynomial of degree 7. That's telling you this is going to be very tedious, because degree 7, look how much work I had to do just to get to degree 3. Degree 7 means I'm going to start off with x to the 7th. So let's look at this one. Find a polynomial of degree 7 with -1 as a 0. So -1 as a 0. And then it tells me it has multiplicity 3. So that's going to mean something. 0 is a 0. And it also has multiplicity 3. And 1 as a 0 of multiplicity 1. So let's think about what that means. I still am going to be turning my zeros into the factors that they came from. But remember what where the multiplicity number comes in? That's what's telling you whether or not it crosses the x-axis or touches the x-axis at that 0. And it's the little exponent above that factor. So let's see, if -1 is a 0, it must have come from x plus 1. Multiplicity 3 means that factor has an exponent of 3. Zero means it just came from x, and its multiplicity is 3. 1 is a 0, which means it must have come from x minus 1, and its multiplicity is a 1. So its exponent is a 1, which means I don't really even need it. All right, I'm looking for conjugates to see if somebody will clean itself up. Now, this one, since it has multiplicity of 3, they're not conjugates. So let's see. I can do it in any order I want. This looks like it's going to be a mess, and because it is. So I'm going to leave that alone for a minute. I'm going to distribute this x to the 3rd to both of those and take care of that multiplying. So x to the 3rd times x just gives me x to the 4th minus x to the 3rd times 1 is x to the 3rd. I'm going to bring down this x plus 1 to the 3rd. So all I've done so far is distribute this x to the 3rd to both of those. So I've taken care of that. So all I need left to do is the x plus 1. But since it's to the 3rd power, I got to figure out, I got to take care of that first. I'm going to do it over there on the side. Because what does x plus 1 to the 3rd mean? It means x plus 1 times itself 3 times. So I got a bunch of foiling within foiling within foiling. So let's see. My first, x times x gives me x squared. My outer, x times 1 is x. My inner, 1 times x is x. And my last, 1 times 1 is 1. I can clean this one up. I can put the x's. I really have 2 x's in the middle. So now I have x squared plus 2x. Plus 1 Drop down this x plus 1. And then distribute this. So the x squared will go to both of those. So let's see, x squared times x, which gives me x to the third. Remember, I'm going to end up at degree 7. So at some point, I'm going to have x to the 7th. So let's see, there x squared times x is x to the third. X squared times positive 1 is x squared. So I'm done with the x squared. Now I'll move on to the 2x and distribute it to both of these. So let's see, 2x times x is 2x squared. 2x times 1 is 2x. I'm done with the 2x. Now I'll move to the 1. 1 times x is x. 1 times 1 is 1. And clean that up. So let's see, I got x to the third. There's all my x squareds. I need to put those together. So I've got 1 here and 2 there, so I really have 3x squareds. There's my x's. I've got 2 here and 1 here, so I really have 3 x's. Bring down my plus 1. So let's see, where was all that from? That's what x plus 1 to the third power. We just worked it out over there to the side since it took up so much room. So x plus 1 to the third gave me x to the third plus 3x squared plus 3x plus 1. So there's x plus 1 to the third all the way out. I need to drop down my x to the fourth minus x to the third. And multiply those together. This is the problem that made me say I'm not doing this the Friday before spring break. So I've got to distribute x to the third to both of those. So let's see, what's x to the third times x to the fourth? What do you do with your exponents when you're multiplying? You're going to add them. So the good news is, where are we at? X to the third times x to the fourth is x to the 7th. So there's my degree 7, which means once I get done multiplying these together and cleaning it up, I will be done because I'm at my I'm at degree 7 now. So let's see, x to the 3 times x to the 4th give me x to the 7th. Now I need to do x to the 3rd times negative x to the 3rd. So get your sign right first. Positive times a negative is a negative. X to the 3rd times x to the 3rd. When you add those exponents together, will give you x to the 6th. So I'm done with this one. Now I'll move on to the 3x squared and give it to both of those. So let's see, 3x squared times x to the 4th gives me 3. Add your exponents, so 3x to the 6th. Get your sign right. Positive 3 times negative 1 gives me negative 3. Add those exponents to get x to the 5th. So I've done the 3x squared. So I've done both of those. Now I'll move to the 3x and do it to both of those. So let's see, I've got 3x times x to the 4th. So I'm going to add those exponents, which will give me 3x to the 5th. And then 3x times negative 1x to the 3rd. So positive 3 times negative 1 gives me negative 3. Got x to the 3rd, so that gives me x to the 4th. So now I'm done with the 3x, and I move to the 1. Very last thing. Now, if I'm multiplying both of those times 1, what happens when you multiply something times 1? Nothing changes, right? So if I multiply both of those times 1, I'm just going to have plus x to the 4th minus x to the 3rd. And then clean it up by combining like terms. So let's see, I've got x to the 7th. You can put your x to the 6's together, right? You've got -1 here, +3 there. So that gives you +2 x to the 6's. Put your x to the 5th. This is about the only good thing about this whole problem. What happens to your x to the 5th? They cancel out, right? You've got -3 and +3. My x to the 4th, I've got -3, +1, which gives me -2 x to the 4th. And then just drop down your minus x to the 3rd. One little mistake in any part of that problem throws it all off. All right, number 6. All right, find a polynomial function of degree 4. So degree 4. So it should be a little better than the last one. With -3 as a 0 of multiplicity 3. And 0 as a 0 of multiplicity 1. So let's see, if -3 is a 0, its factor was x plus 3. And its multiplicity was 3. The multiplicities are what make it difficult. If it's more than 1 or 2, it's going to have a lot of work. 0 is the 0, which means it came from just x. And its multiplicity is 1. So that x, I don't even need to write out its exponent. So I'm going to do this first. Because what does x plus 3 cubed mean? X plus 3, x plus 3, x plus 3. Because then once I do that, I'll just have to multiply whatever that ends up being times x, which means I'll just distribute x to all the terms. So let's do this first. X plus 3 cubed. So let's see, I'll FOIL here. X times x gives me x squared. X times +3 is +3x. My inner is another +3x. And my last, 3 times 3 is 9. Like terms in the middle, so I can put the 3 x's together to get 6x. So I've got x squared plus 6x plus 9. So that's what those ended up being. I still have this other x plus 3 that I need to bring down. And I'll multiply it. So let's see. Here I've got x squared times x. So there's my x to the 3rd. X squared times +3 is +3x squared. So I'm done with the x squared. Move on to the 6x to to both of those. 6x times x gives me 6x squared. 6x times 3, 18x. So I'm done with the 6x. Now I'll move on to the 9. So 9 times x is 9x, and 9 times 3 is 27. Clean it up. Put your squareds together and your x's together. So I'll bring down my x to the third. Put my x squareds together. I've got 3 here and 6 there, so I actually have 9x squareds. Put your x's together. I've got 18 here and 9 here, so I actually have 27x. Bring down my plus 27. Almost done. So that took care of the x plus 3 to the third, right? That's what all that did, was just that x plus 3 to the third. I still have that x that I need to multiply all of this by. But I'm just distributing an x to all of these, which means they're each going to gain an x, right? Because what's x times x to the third? It's x to the fourth. X times 9x squared, so that'll just make that 9x to the third. X times 27x, we'll just turn that into 27x squared. And x times 27 just turns that to 27x. And now you're done with that. Now, on problems 7, 8, and 9, it's going to give you some zeros, and the zeros that are going to be included, some of them are going to have i's, and some of them are going to have square roots. So remember in problems 2 and 3, when it listed 3i as a 0, it also listed negative 3i. On number 3, when it listed square root of 5 as a 0, it also listed negative square root of 5. Because if you have one of those that has a radical or an I, the conjugate of it or the opposite sign of it is also included. It's also going to be a 0. Okay? So these problems sound like they're going to be difficult, but really, you're just looking for any zeros that have radicals or i's, and then putting in the opposite as also 1. I'll show you what I'm talking about. On number 7, it says, suppose a polynomial 4 has the given number of zeros, negative 4, square root of 2, and 9/4. Well, if it's degree 4, it actually only has one more 0, right? I've got 3 zeros listed. So there's 1 missing. So what I'm doing is looking for anybody that's a radical or an I. So this one right here. If square root of 2 is a 0, so is negative square root of 2. So that's your other 0. Number 8, same thing. So that's just simply your answer to number 7. That's the missing 0. On number 8, it gives me 2 zeros, and it says it's degree 4, which means it's going to be missing 2 zeros. The zeros it gives me are negative I and 4 minus the square root of 7. Well, if those two are zeros, if negative I is a 0, so is positive I. If 4 minus the square root of 7 is a 0, so is 4 plus the square root of 7. So you're just using the opposite conjugates. Number 9, one more like this. Another degree 4, but it only gives me 2 zeros. 1 plus 2i and 5 plus the square root of 5. If it's degree 4 and I'm given 2 zeros, there's 2 zeros missing. Well, 1 plus 2i, which means 1 minus 2i is a 0. 5 plus the square root of 5, which means 5 minus the square root of 5 is a 0. All right, one more problem. I'm going to work number 10, and then we'll start with number 11 on Wednesday. So number 10 is another problem that starts off like this, saying find the missing zeros, but then once you find that missing zero, it wants you to turn all the zeros into factors and then multiply them together. So, number 10, it says, find a polynomial function of lowest degree with these zeros, negative 2i and 3. Well, the first thing I need to realize is that if negative 2i is a 0, then it's missing the positive 2i since it's not listed. So I need to write that up there first. That's just a plain number. If it's not a square root or an I, it doesn't have to, there's nothing missing from it. So I found my missing 0. Now, just like all the other ones that I've worked today, I need to turn those into the factors that they came from. So let's see, if that's a 0, that means it came from x minus 2i. This one came from x plus 2i, and this one came from x minus 3. Now remember, anytime your factors are conjugates of each other, you want to do those first because they clean each other up. So let's do this one, these two first. X times x, x squared. My outer, x times positive 2i is positive 2x, I. Here's why they clean each other up. What's the inner? Negative 2x, I. And my last, negative 2i times positive 2i gives me negative 4i squared. Those middle two terms knock each other out. So there's my x squared. Now remember, anytime you see I squared, that turns to negative 1. So this really says negative 4 times negative 1, which means it's really plus 4. Right? This right here, the negative 4 and negative 1 together turns to plus 4. Drop down your x minus 3. Multiply them together, and we're done. So x squared times x gives me x to the third. X squared times negative 3 gives me negative 3x squared. 4 times x plus 4x, and 4 times negative 3 is negative 12. And when I get down here, I notice that everybody's in the right order and there are no like terms. So you're done. All right, online I got Davis, Macaulay, and Gabriella. And here I have